when we have a quadratic with an a value, the first thing you do, just like if you didn't have an a value, is your x method. Remember? Yes. And what goes up top? I heard someone say it. Yes, a times c, which we have a, b, oh, I said a, I put c, a, b, c. So a times c is what here? 9. And our b value is? And what do we ask ourselves? Yes, what multiplies to give you 9? So what multiplies to give you the top number, but adds to give you the bottom number?
-1, -9.
Yeah. -1, -9. Now here is where most people are going to go wrong. Don't write this. They're going to write this and say, oh, our solutions are 1 and 9. I guarantee at least 3 of you probably will do this on the test. What's wrong with this? Why isn't it right? It has something to do with the 3 out in front. If we have an a value, can you just do the x method and say, oh, those are my factors? Nope, you got to do more work. So when you have an a, I don't know how Miss D showed you, or I don't know how other teachers showed you in the past. There's multiple ways to do it, but this is my favorite. It's called factoring by grouping. So we do the x method just like normal. Then what you do is you take down your first term and your last term from the original equation. Then the 2 numbers that you found in your x go in the center with x's on them. So we have -1x and -9x. Basically, all that the x is doing here is taking your middle number, your -10x, and splitting it into 2 numbers that will be factorable when we factor by grouping. Okay? That's all that the x is doing. See how it's splitting it into -1 and -9? Because if we were to combine like terms here, it'd be -10x. We're just splitting it apart. So now comes the factoring by grouping part. We group the first 2 terms and the last 2 terms. Does anyone remember what to do from here? Yes, you take out the greatest common factor from both groups. So what is our greatest common factor between 3x squared and -1x? Yeah, 1x. So we pull an x out. What is 3x squared divided by x? 3x. What is -1x divided by x? -1. Then we pull the GCF out of the second 2. So what is -9x plus 3? What's the GCF between those 2? A 3. So I'm going to pull a 3 out. Ooh, just a 3? I'm going to pull, oh my gosh. I'm going to pull a -3. So what's -9x divided by -3? Positive 3x. And what's positive 3 divided by -3? The reason why we also pulled the negative out is because our goal is to make the inside the parentheses the same. So is inside of our parentheses the same? Yes, that's how you know you're doing this right. That's why we split 10x into -1x and -9x, because it makes the inside of the parentheses the same. So now, what is our last and final step to factor this here? What do you notice about both of those 2 terms we have now? Ah, okay. So both of them have 3x minus 1 and 3x minus 1. Yes, you pull it out. It's another GCF between those 2. So you pull out 3x minus 1. And then we're left with what? x minus 3. Guess what? Those are now two factors. Two terms, two parentheses that multiply to get your quadratic. So the two parentheses are combining to create one of the factors, and the leftovers are the other factor. Now what do you do to this to then find the solution? You just set each one equal to 0. So 3x minus 1 equals 0. And what do we do to get x by itself? Add 1 to both sides and divide by 3. Now, do you need to show me this on your paper, this simplistic math solving for a linear equation? Not really. All of that is kind of extra that most of you can probably do in your head right there. And then x minus 3 set equal to 0. And we add 3 over. X is 3. So our solution set is what here? Yeah. 1/3 and 3. Does it matter what order those go in? Do you think? Does the order matter? No, doesn't matter. Any questions on how to use factoring to find solutions? If you have a different way of factoring when there is an A value and you're solid on it and you can do it every single time, go ahead and do it. But if you're not solid, if you don't know how to factor when there's an A value, use my factoring by grouping method, okay? Yes? Yes. Okay, so I know that this is kind of tricky here, this last step. So, how many different terms are we looking at when we have x times 3x minus 1 minus 3 times 3x minus 1? Technically, how many terms are here? It's a lower number than you think. There's 2 terms, right? There's 2 things actually being subtracted here in total, because the first grouping is all being multiplied. That's a number times parentheses, and the second grouping is a number times the parentheses. So because we have a parentheses times a number and a parentheses times a number, we can pull out the greatest common factor. We can pull out a GCF from both of those. So if I'm looking at this first term and this second term, between the two of them, they both have a factor of 3x minus 1. So what I can do is I can pull that 3x minus 1 out. So if I'm pulling from this first grouping 3x minus 1 out, what am I left with? If I cross that out. Why is this not working? What am I left with? An x. If I'm pulling 3x minus 1 out, what am I left with? That's where those came from. Does that make sense? If it still doesn't make sense, just remember, oh, the parentheses are one of the factors, and outside of the parentheses go together to create the other factor. Yes?
So like when there's not an A value?
You don't have to do all that. Very good question.
-9, -1?
Yes.
Okay.
So if there hadn't been a 3 here, it would have just been x minus 1, x minus 9, and then our solutions would have been x equals 1 and x equals 9. Okay? Any other questions? Did you guys not factor with an A value at the beginning of the year?
We did.
It just wasn't explained like this.
Okay.
It was just cheap. Here you go. It really was.
All right. So I want you guys to go ahead and do A, C, and D and find the solutions for A and D. You cannot find the solution for C there because there are 2 variables, okay? So factor each one of these and find the solutions for A and D. Oh, because I decided to do the hardest one first, it actually seemed to screw you up a little bit because then you tried to do the hard method the entire time, right? So for this A, do we have to factor by grouping? Do all this over here like I did before? No, why not? Yes, there is no A value right here. Why is this not writing? Okay, yes, there is no A value right there. So all we have to do is the first part. All we have to do is create our X, put A times C in the top and B in the bottom, and we get negative, what do we get? Beautiful. So our factors are X minus 5 and X plus 1. Because there is no A, I didn't need to bring down the first term, bring down the last term. Why is it not writing? Bring down the first term, bring down the last term. We don't have to do that. And now to get the solutions, we just set each one equal to 0. So we have X equals 5 and X equals negative 1. Should have been our solution set there. Now, see, a lot of people's brains didn't quite remember what to do here. We have what that is special going on here? They are both perfect squares, and what's between them? A negative. That means we can use what? Difference of squares. So we square root everything. What is the square root of 9x squared? 3x. What's the square root of 16y squared? 4y. And what do I do between these two terms? I add and subtract them. Can you then find the solutions from here? Why not? There's two variables. What did you learn? What was it? Unit 2? What did you learn you need to do in order to find or solve for two variables? Right. In order to use substitution, you needed two what? Two equations. For every variable you have, you need an equation. So I only have one equation here. I can't solve for both. All right. D, what did you guys get? Yeah. Is it 3, negative 1? Yeah, right? Those are the right 1, negative 3? Do I have to do it? That's right. Okay, good. That's right. 3, negative 1. What did a lot of people forget to do that they realized had them do a lot more work than they needed? You always should look for a GCF first. It makes your life a lot easier. Could you get this right without taking the GCF out first? Yes. But guess what? It's like 4 or 5 more steps than you needed. So we take a GCF out first, we take that negative 2 out, and then it's just X method. We don't have to factor by grouping. Any questions on any of these? All right, before we start our practice for today, I do want to go over a couple things here. So if I had this, what is going on? Okay, if I had this, and I said find the solutions, oops, and I said find the solutions, what would you do? I heard someone say it quietly. You always look for what first? So what can you pull out? A 2x. So this just becomes x minus 2. Guess what? These are my favorite because it's literally only these 2 steps. Boom, you have your factors. My 2x equals 0 is my first solution. Divide by 2, x is 0. My second solution, x minus 2 equals 0, x equals 2. So my solution set is 0, 2. Done. Love those. What else would they give you maybe? Ooh, yes. What would I do to solve that? Why'd I make that negative? Make it positive. So the easiest way to do this, yes, you can bring it over. You can actually do difference of squares, solve it that way. Or because you don't have a b value, You can square root both sides. So we have, what is the square root of x squared? What is the square root of 36? Is it? Just 6? Ah, plus or minus 6. So our two solutions are x equals 6 and x equals negative 6. So our solution set, negative 6 and 6. So all this stuff you guys should have done in the beginning of the year. I know it was a long time, couple months, right? All right.